Hi guys, it's Mr. Moberg, and this screencast is answering the question, what is the law of conservation of matter? Throughout it, you're definitely going to want to take notes, so find an appropriate place to do that. And if you have any questions whatsoever on the material in this screencast, please ask questions of either your teacher or people around you. First question I want you to discuss with people nearby, is it possible to destroy matter? How about create it? I think this is a really fun conversation to have, so I'd like you to invest some time right now and pause your screen and talk with people around you. Okay, now that you've had a chance to talk about that, I will revisit the answer to this at the end of the screencast. Before we get into it, I want to just clarify a few things, make sure we all know. Matter is everything we see and sometimes don't see around us. It must have mass or be made of particles. And those particles must take up space. They must have volume. We've also established right now that matter can change. It can change in two ways. Physically, where we change something about the matter but don't change what it is. And it can change chemically, where we create a new substance that we didn't have before. Let's break down the meaning of the law of conservation of matter real quick. So what is a law? A law is something that will happen. We can count on it every time. It's never broken, no matter what, just like the law of gravity. When we drop something, it's always going to fall. That next word, conservation. When you hear the word conserve, you may have heard of conserving resources like water. And when we conserve, we try to save. So in this case, matter is saved. So the law of conservation of matter says that matter cannot be created or destroyed, only transformed or changed. I really like the example you see here on the screen. We have Legos. These represent particles. When they change, they're rearranged to make something new and different. But in the end, we still have the exact same amount of Legos. That word transform, you may have seen the root word trans before, like transformers. They change from one thing into another. Or if we've seen that word translate, where we take one language and make it into a new one. Apply that now to matter. Matter transforms. It turns from one thing into something new and different. Going forward, you're probably going to see the word LAWCOM going forward. So anytime you do, the word law of conservation of matter is summed up with the saying LAWCOM, which stands for that. Here are some examples. The input, what you start with, equals the same amount of stuff you end with. You're not losing particles. They're not being destroyed. They're not being created. They come from somewhere, in this case the pile, and they turn into something else. Here's another example with an airplane. The amount of particles that you start with, here on the left, the inputs, equal the amount of particles you end with, the outputs. Another example, if I had two gray molecules to start off with, these are my inputs. They're going to equal, I'm going to have two gray ones at the end. If I have two red ones at the beginning, I'm going to have two red ones at the end. When the matter changes, we don't make new matter. We just rearrange it and turn it into something else. Here's a great specific example with a chemical reaction. Here in the left here, we have a few different chemicals inside a flask on a balance. The balance reads 67.25 grams. Once we mix them together and they react, and they make a new substance, we're rearranging the particles, but we still have the same mass of 67.25 grams. Note here, there's a cap on the flask so that no matter can come in and no matter can leave. I'd like you to pause your screen and discuss this question. Use the image below to explain the law of conservation of matter. What is the mass of the outputs? So how does this picture show the law of conservation? And if we had 12 grams to start off with, how many grams do we have to end with? Pause your screen, talk with this about with people nearby. Okay, now that you've had a chance to talk about it, the mass of the outputs should be 12 grams. This shows the law of conservation well because we have the same amount of particles at the beginning and the same amount of particles at the end. Last conversation question I want you to have with people around you. Choose several examples in the image to the left and explain how the law of conservation of matter applies. So talk about when we melt ice. Well, we have ice, we still have the same amount of particles in the end, they've just changed state. Choose a few more, talk with those around you, apply this idea. All right, coming back to our warm-up question, is it possible to destroy matter? How about create it? The answer is no. Even in an atomic bomb or burning things, we're just changing the matter. We're moving it around. We're making new and different things. But the amount of particles we have at the beginning always and must equal the amount of particles we have at the end. So let's recap all these ideas real quick. So the law of conservation of matter, or LACOM recap. Matter is made of mass. That mass can change. When it changes, it can be transformed, but it is not destroyed or created. And lastly, the mass of the product always equals the mass of the reactants, or the inputs must equal the outputs. Thanks a lot for watching. I really hope this was helpful. Like normal, please ask your teacher if you have questions or ask those around you. We'd be happy to help.